Hi guys, Circles in here, and in this video our topic is integration by partial fractions. I hope you still remember the techniques that were discussed during the lecture, so I will immediately go to the problems that I have prepared for this video. So let's go. So for our first problem, we have the integral of 5x plus 1 all over 2x plus 1 x minus 1 dx. So we start with the rational function 5x, 5x plus 1 divided by 2x plus 1 times x minus 1. So we have here two linear expressions on the denominator, which means that this rational expression here can be written as a over the first linear expression in the denominator, which is 2x plus 1, then plus b over the second expression there in the denominator, which is x minus 1. And then this expression on the right hand side can be written as a times x minus 1 plus b times 2x plus 1 all over the denominator 2x plus 1 times x minus 1. So what we do here is since they have the same denominator now, we compare the numerators. So basically, we will have the expression or the equation 5x plus 1 equals a times x minus 1 plus b times 2x plus 1. So we solve the values for a and b, and to do that, what we can do is to use or to substitute a value for x that will make one of a or b disappear in the equation. So for example, we can let our x here, we can let our x to be equal to 1, okay? So if we let x equals 1, this expression here or this term here will vanish because at x equals 1, x minus 1 here it's equal to 0, while this expression here when x equals 1 will not vanish. So more precisely, when x equals 1, left hand side, this is equal to 6. That's 5 times 1 plus 1, that's equal to 6. While on the right hand side, we will have b times 2x plus 1. So 2 times 1, that's 2, plus 1, that's equal to 3, which means that the value of b here, this is equal to 6 over 3, which is equal to 2. On the other hand, we can choose x equals negative 1 half, because if we chose x equals negative 1 half, this term here will disappear. And we will be able to compute for the value of a. So, when x equals negative 1 half, okay, let us compute this completely. You have 5 times negative 1 half plus 1 on the left hand side. On the right hand side, we will have a times negative 1 half minus 1. And as I have said, this term here, 2 times negative 1 half, that's negative 1 plus 1, that becomes 0. So this term here will vanish. So if we simplify the expressions here, we will have a equals, so this is negative 5 halves plus 1, that's negative 3 halves, all over. Here you have negative 1 half minus 1, that's again negative 3 halves. So you will have negative 3 halves, and therefore a is equal to 1. Okay? A equals 1. Which means we have this integral here. This integral here can now be written as the integral of a, which is 1 here. So 1 over 2x plus 1 plus b, which is equal to 2 here. So 2 over x minus 1 quantity dx. So we can now integrate this easily and obtain ln, absolute value of 2x plus 1 divided by 2, because we have here a linear expression with coefficient equal to 2 here. That's where this over 2 would come from. And then for this guy here, we will have plus 2 ln absolute value of x minus 1, and then we have the plus c. So this is the final antiderivative of this expression here. Okay? For our next problem, we want to integrate x squared over x squared plus x minus 6 dx. So observe here that the rational expression has numerator x squared and denominator x squared plus x minus 6. That is, they have the same degree. So our first step here is to simplify this expression. Maybe we can do long division, or maybe we can add or subtract something in the numerator so we can simplify the expression. So verify that we can add and subtract x minus 6 in the numerator so that we will obtain 1 minus x minus 6 divided by x squared plus x minus 6 in the integrand of this expression. Okay, so try to verify that this integral here is equal to this. So of course, if we integrate 1 dx, we can easily get the answer. As for x minus 6 all over x squared plus x minus 6, we use integration by partial fractions. So here we have x minus 6 divided by x squared plus x minus 6, and you have to realize that the denominator can be factored into x minus 2 x plus 3, which means that this expression here can be decomposed into a over x minus 2 plus b over x plus 3. And as in before, we combine into single rational expression again. We will have a times x plus 3 plus b times x minus 2. And then divided by x minus 2 times x plus 3. So if we compare numerators, we will have the equation x minus 6 equals a times x plus 3 plus b times x minus 2. And again, we substitute values to the variable x, so we can solve for a and b. And in this particular equation, we can substitute some number to x so that one of the terms here on the right hand side vanishes. So if we let x equals negative 3. This term here will disappear, okay? And we will be able to solve for b. So when x equals negative 3, left-hand side equals negative 9, while the right-hand side equals b times negative 3 minus 2, that's negative 5. And so, b equals 9 over 5. Now, if we let x equals 2, this term here will disappear. And we will be able to solve for a. So for this, when x equals 2, we have 2 minus 6 on the left-hand side. That's negative 4. On the right-hand side, we have a times 2 plus 3, which is 5, which means that a equals negative 4 over 5. Therefore, going back to the integral here, we have integral of 1 dx, that's just x, then minus integral of a over x minus 2. A, it's negative 4 over 5. So negative 4 over 5 divided by x minus 2 dx. And then, anyway, so let's write this in single integral. So let's put the dx later. And then here plus b over x plus 3. B, it's 9 over 5. So we have plus 9 over 5 all over x plus 3. And then quantity, we have the dx. Which means if we integrate this now, we'll get x here. Then we have here minus minus, so that's plus 4 over 5 ln, absolute value of x minus 2. And then here minus, so we have minus 9 over 5 ln absolute value of x plus 3, and plus the arbitrary constant c. So this is the final answer for this integral. Next problem, we have the integral from negative 1 to 0 of x cubed minus 4x plus 1 all over x squared minus 3x plus 2. So in here, observe degree in the numerator, it's 3, while the degree on the denominator, it's 2. So we do long division here to simplify at least this rational expression. You have x cubed minus 4x minus 1 or plus 1 divided by you have x squared minus 3x plus 2. That's 3x there. So divide, you have x, and then x times x squared, that's x cubed, x times negative 3x, that's minus 3x squared, x times 2, that's plus 2x, and then we do the subtraction. We do this subtraction here. So x cubed minus x cubed, that will disappear. This doesn't have any squared term, so we'll just bring this down, of course, with the negative applied. So this becomes positive 3x squared. And then here you have minus 4x minus 2x. That's minus 6x. And then here, there's no constant term for this guy here, so we just bring down the positive 1 from this term here. And then next, this is 3x squared and this is x squared, so we can still do the division. So you have plus 3, then 3 times x squared, that's 3x squared, then 3 times negative 3x, that's minus 9x, and then you have 3 times 2, that's plus 6. And again, we do the subtraction. We will have 3x squared minus 3x squared, that will disappear. We have minus 6x minus negative 9x, that's positive 3x. And then 1 minus 6, that's minus 5. And now we have this. So this expression here, we can rewrite as the integral from negative 1 to 0. And then we have the x plus 3 there, x plus 3. And then we have plus 3x minus 5 all over x squared minus 3x plus 2. Then we close this. Okay, we close this. Then we have the dx. Now, this expression here we can integrate easily. For this expression, we use integration by partial fractions. So we look at this expression now. Okay, we look at that expression now. We have 3x minus 5 divided by x squared minus 3x plus 2. And you should be able to factor the denominator easily into x minus 2, x minus 1, which means that this here can be decomposed into a over x minus 2 plus b over x minus 1. And again, we combine them. We will get a times x minus 1 plus b times x minus 2 divided by x minus 2 times x minus 1. And then again, we compare 3x minus 5 with a times x minus 1 plus b times x minus 2. Okay? So here, we will have, so 3x minus 5 equals a x minus 1 plus b, so plus b x minus 2. Just like before, we use some values for x to solve either a or b, and we choose x so that one of them vanishes. So here we say let x be equal to positive 2. Okay, sorry, I think, oh yeah, this is good. X equals positive 2. This term here will disappear. So on the left hand side, you have 3 times 2, 6 minus 5, that's 1. While on the right hand side, we will have, so this will vanish, 2 minus 1, that's just 1, so we have a. And then if we have x equals 1, so this term here will vanish. And when x equals 1, here we will have 3 times 1 minus 5, that's negative 2. And then equals b times 1 minus 2, that's negative 1. And that we have b equals 2. Which means now we have the integral here. Integral from negative 1 to 0 of x plus 3. Okay, plus you have a, which is 1, over x minus 2, and then plus b, which is 2, over x minus 1. Okay, and then we close this and then integrate now. With respect to x, we will have x squared over 2 plus 3x plus ln absolute value of x minus 2 plus 2 ln absolute value of x minus 1. And then this is definite integral, so we evaluate from negative 1 to 0. So at 0, we will have ln of 2. And then in here, you have ln of 1, so that's just 0. And then minus quantity. At negative 1, we have 1 half here. And then we have the minus 3 here. And then in here, you have ln. So plus ln absolute value of minus 1 minus 2, so ln of 3. And then in here, plus 2 ln of 2. Okay, and then we can close this. You can simplify if you want, but we can accept this as the final answer. Okay. For our next problem, we want to integrate 1 over x squared of x plus 1 dx. So in here we combine u substitution and integration by partial fractions. So we start with u equals square root of x plus 1. Then our du, this is equal to 1 over 2 square root of x plus 1 dx. And therefore, this expression here, okay, can now be replaced as the integral. So in here, we will have 2 as a coefficient of du. So we bring this 2 on the other side. So you will have 2 du, okay? And then this and the dx will be taken by that 2 du. And for the x here, we see from this expression here, we can write x as u squared minus 1. So this is equal to x. Therefore, the denominator here is just u squared minus 1. Okay? And for this, we know that we can easily factor u squared minus 1. So we just have to write 2 over u squared minus 1. This is equal to a over u minus 1 plus b over u plus 1. And again, combine this into a single rational expression. We will have a times u plus 1 plus b times u minus 1 divided by u minus 1, u plus 1. Okay, which means, so in here, let us think that the numerator 2 is equated to the numerator a u plus 1 plus b u minus 1. So we directly start substituting. So first, say u equals negative 1. So this term here will vanish. Okay, and we will get 2 equals b times negative 1 minus 1. That will be equal to negative 2, which gives us b equals negative 1. And then if u equals 1, this term here will vanish, and we will have 2 equals a times 1 plus 1, which is 2, which gives us a equals 1, which means this expression now can be written as 1 over u minus 1 minus 1 over u plus 1. And then we have the du. And simplifying, this is, or integrating, I mean, this is ln absolute value of u minus 1 minus ln absolute value of u plus 1 plus c. And then we bring back the variable x via this substitution here. So this guy here equals ln absolute value square root of x plus 1 minus 1 minus ln absolute value of square root x plus 1 plus 1. And then the plus c there. So this is our integral for this expression here. Okay? Our next problem here, we want to integrate 1 over x cubed minus 1. So our denominator, it's a cubic expression, and in particular, it's a difference of 2 cubes. And you have to recall the factorization of a difference of 2 cubes. Okay, so recall that your x cubed minus 1, you can factor this into x minus 1 times x squared plus x plus 1. So this guy here, x squared plus x plus 1, it's already a prime polynomial in our sense, meaning we cannot factor this anymore. Okay, so if we try to decompose 1 over x cubed minus 1 into its partial fractions, we would expect a denominator with x squared plus x plus 1, and its corresponding numerator will be a linear expression. Okay, so here we have x 1 over x cubed minus 1. For the factor x minus 1, let's just write a over x minus 1 plus, for the factor x squared plus x plus 1, the numerator will be written as bx plus c divided by x squared plus x plus 1. So the numerator is bx plus c. And then as usual, we combine into a single rational expression, this right-hand side here. So we write it as a times x squared plus x plus 1 plus bx, oops, here we have bx plus c multiplied to x minus 1. And then we copy the denominator, but let's write the denominator as x cubed minus 1. Okay, so again, we compare numerators. We just equate 1 to a times x squared plus x plus 1, and then plus quantity bx plus c times x minus 1. So we substitute x with some values that will help us solve a, b, and c. Okay, our first substitution would be x equals 1, because if we do that, this term here will vanish and we will be able to get the value of a easily. So here we have x, or we let x equals 1. On the left hand side, we still have 1. On the right hand side, we have a times 1 squared plus 1 plus 1. So we'll just have a times 3. And therefore, we have a equals 1/3. Okay? Now we have a value for a. We can easily substitute that value a in this term here. Then we are left to solve for the values of b and c. What we can do in here is to let x equal 0 so that this bx term here will vanish, and therefore we will be left with c. Okay? So in here, we let x equal 0. On the left-hand side, we have 1. On the right-hand side, we have a, which is 1/3 already. And then we have here 0 plus 0 plus 1. So we just have a times 1. So here we only have 1/3, then plus. So again, at x equals 0, bx disappears. So we only have the plus c here. C times x equals 0. So this guy here now becomes 0 minus 1. So c times negative 1. So for this expression, okay, this guy here, we solve for c. We bring c to this side. We bring 1 to the other side so that we will get c equals 1/3 minus 1, which is equal to negative 2/3. Okay? And then we can solve for b now by using some other numbers. We substitute the value of a as in before, and then we now have the value of c. We substitute it here, and we will be left with the value of b. Okay, so maybe we can use x equals negative 1. So when x equals negative 1, left-hand side it's 1. Right-hand side, you have here a, which is 1/3. And then here you have negative 1 squared, that's 1. This is minus 1 and then plus 1. So again, this expression here, it's just 1. So we only have that 1/3. And then plus. We have here bx, okay? But x equals negative 1. So we'll just have negative b, okay? And then you have the plus c here, but c is equal to negative 2/3. So we have minus 2/3, okay? And then negative 1 here, we have here negative 1 minus 1, that's negative 2. And then we just solve for the value of b. So here we will have 1 minus 1/3. This is equal to, we have negative here and negative, so we multiply that or those negatives there. We'll just get 2 times b plus 2/3. Okay, b plus 2/3. And this guy here, 1 minus 1/3, we get that to be 2/3. Correct? And therefore, what do we get? We divide everything by 2 for this coefficient here to get b plus 2/3. b plus 2/3 equals 2/3 divided by 2, that's 1/3. So this guy here gives us b equals 1/3 minus 2/3, 1/3 minus 2/3, and this is equal to negative 1/3. So we have the value for a, we have the value for c, we have the value for b. We now write this integral up here as the integral. We have a over x minus 1, a is 1/3. So we have 1/3 all over x minus 1 plus. And then this guy here. We have negative 1/3, that's your b in here, negative 1/3 x. And then here we have c equals negative 2/3. So minus 2/3 all over x squared plus x plus 1 quantity dx. Okay? Then we continue our solution. Of course, for the first guy here, this is just ln absolute value of x minus 1 times the 1/3 there. And then for this guy, okay, let us rewrite it. Okay, so for the first term, we have 1/3 ln absolute value of x minus 1. And then here, let us factor negative 2/3. Okay, so we will have here minus 2/3. So minus 2/3. Okay, and then what do we get? No, let us just factor negative 1/3. So in here, we factor negative 1/3, and then we will have the integral. In the numerator, you will have x plus 2, while the denominator will have x squared plus x and then plus 1. Then you have the dx. Okay? Let us continue working on this expression. So I think you have to remember the technique that were taught to you in your lecture. So maybe we can make some adjustments in the numerator so that we can use first the substitution rule, and then we can separate some constant in the numerator, and then its denominator is this quadratic expression here, and you can use your trigonometric substitution. Okay, so let us manipulate this numerator here. Okay, let us look at some way in order to put 2x plus 1 in the numerator. So you have your x plus 2, okay, x plus 2, this x here, okay, this x here, we can rewrite it as 2 over 2x plus 2, okay, 2 over 2x plus 2. So 2 over 2x plus 2. And then from here, we factor out 1/2. Okay? We factor out 1/2. We have 1/2 times 2x. Okay? And then for this, since we factored out 1/2, this becomes plus 4. Correct? If you don't believe me, just distribute this 1/2. That will give you x plus 2. And then we want here the 2x plus 1, as I have mentioned here. The 2x plus 1, we want to have 2x plus 1. So I will separate the plus 1 from the plus 4. We will have 1/2 times 2x plus 1, and then you have your plus 3. And therefore, we can rewrite x plus 2 as 1/2 2x plus 1 plus 3/2. Okay? which means we can replace now x plus 2 by this expression, and therefore we can use on this part here we can use substitution rule, while on this part we use trigonometric substitution. Okay, so here we have now 1/3 ln 1/3 ln absolute value of x minus 1 minus 1/3 integral. For the first guy here, we have 1/2 2x plus 1 divided by x squared plus x plus 1 dx. And then here you have the 3/2 part. So minus 1/3, okay, minus 1/3 integral of 3/2 over x squared plus x plus 1, and then let me put the dx here. Okay? Question so far? So in here we can let u be equal to x squared plus x plus 1. The du becomes 2x plus 1 dx. Okay? Which means this guy here is just ln of the denominator. So please show the work for that. Here you will have u equals x squared plus x plus 1, du equals x or 2x plus 1 dx, which gives us, so for this part, we will have 1/3 ln absolute value of x minus 1 minus, we have 1/3 and 1/2, that's your 1/6, and then ln absolute value of x squared plus x plus 1. As for this guy here, we have minus. So 1/3 and 3/2 here. So 1/3 and 3/2, that becomes 1/2. And then we rewrite the integral as dx over. Complete the square. Okay, try to complete the square. We can write this as x squared plus x plus 1/4 plus 3/4. Okay? Follow? All right. So let me work on this here only. So we will have minus 1/2 integral of dx divided by x plus 1/2 squared plus 3/4. Okay? Then, what will happen to that? We use trig sub. It's a plus. Okay, it's a plus. So we continue in here. So we can let what? X plus 1/2. X plus 1/2. This is equal to, say, tangent theta. But our A here, it's 3/4. So we let square root of 3/2 tangent theta, and then dx, this is equal to square root of 3/2 secant squared theta d theta, and this guy here becomes negative 1/2 dx. You have square root of 3 over 2 integral of secant squared theta d theta all over what? You can get this guy here. So this will be 3/4 secant squared theta. Oh, it's just arctangent. We should have skipped that. We should have skipped this part. We can just write the arctangent of something. But anyway, since we're here already, this is now equal to what? The negative 1/2 times square root of 3 over 2 will cancel. So the denominator 4 here will cancel the denominator 4 here. So what will be left? It's negative 3 or negative square root of 3 over 3 arctan of x. Is that it? Because it's just theta. So from here, you will have 2 over square root of 3 times x plus 1/2. So fill in the details. That's what you will get in this part. Okay? Fill in the details. Because here, cancel, you just have integral of d theta and integral of d theta. That's just theta. So you compute for your theta here, you will get this expression here. And of course, you have the plus c, which means that, therefore, integral 1 over x cubed minus 1 dx, this is equal to, let us go back to the previous slides, and let me copy this part. We have this guy here, okay? We go to the next page here. So we have this, okay? And then this guy above here. So square root of 3 over 3 arctan of 2 over square root of 3 x plus 1/2, and then you have the plus c. Okay? There should be no negative on this part here. So let me erase that negative. Okay? So if we go back, so yeah, that's just 1/3 ln of x minus 1 minus 1/6 ln of something. So it's this guy here. So this is our final expression. Okay? Question.
So for our next problem, we want to integrate 2x to the 4 minus 8x plus 12 all over x to the 4 plus 4x squared dx. So here we observe that the numerator and denominator have the same degree. So we start our solution by doing some long division to simplify this expression. So we have 2x to the 4 minus 8x plus 12 divided by x to the 4 plus 4x squared. So we divide 2x to the 4 divided by x to the 4, we just have 2. Then we multiply this to this divisor, we get 2x to the 4 plus 8x squared. And then we subtract and we will get 2x to the 4 minus 2x to the 4, that will be 0. Here, this doesn't have squared term, so we just bring down that minus 8x squared, and then there are no more terms here, so we just bring down minus 8x and then plus 12. So this expression here, okay, this integral here becomes the integral of 2 plus minus 8x squared minus 8x plus 12 all over x to the 4 plus 4x squared. And of course, this guy here we can integrate easily. For this guy, we use integration by partial fractions. Okay, so how do we do that? Well, let me erase this part here so I will have some space for the computation. So, let's look at this guy. Let's look at this guy. We want to integrate, okay, we want to integrate minus 8x squared minus 8x plus 12 divided by x to the 4 plus 4x squared. And note that this x to the 4 plus 4x squared can be factored into x squared times x squared plus 4. Okay? So we have minus 8x squared minus 8x plus 12. Let's put the factor form of the denominator here. We have x squared times x squared plus 4. So this guy here can be decomposed into a over x coming from this x squared plus b over x squared, okay, because it's a repeating factor, and then plus, and then here we have a linear numerator, cx plus d divided by x squared plus 4. And then once again, we combine into single rational expression. We will have ax times x squared plus 4 plus b times x squared plus 4, and then plus quantity cx plus d times x squared, and then everything divided by this expression here. And then let me write this as x to the 4 plus 4x squared. Okay? And then as in before, we compare the numerator and then the numerator of the left hand side and the numerator of the right hand side. Okay, we equate them, and then in order to solve for a, b, c, and d, okay, we just simply substitute values for x, okay, and then we compute accordingly. So say when x equals 0, look at this, left hand side equals 12, and then here on the right hand side, when x equals 0, this guy here will be 0. Okay, this guy here, x squared becomes 0 squared, so you will have 4b. Okay, and then this guy here, cx will disappear. Well, this x squared here will disappear. Okay, this x squared here will be equal to 0, so this factor here will disappear. So this means that we can easily get b equals 12 over 4, which is equal to 3. So we now have a value for x. Maybe we can use now x equals 1. Okay. So let us see what we can get in here. Okay. So when x equals 1, we will have 8 times 1, and then here you have 1 squared plus 4 on the right hand side. Let us start with the left hand side. So if x equals 1, you have here minus 8 minus 8, that's minus 16, plus 12, that's minus 4. And then on the right hand side, here we will have a 5a, correct? 5a. And then here we already know that b is 3, so we'll just have 3 times 5. Okay, so let's write 15. Again, that is from here, p equals 3, and then this guy here is 1 plus 4, that's 5. So that's 15. And then in here, when x equals 1, we will have plus c plus d. X equals 1, this is just 1, x squared until 1. So that's just c plus d. Okay? So that's x at x equals 1. Let us use x equals negative 1. Okay? X equals negative 1. This is still negative 8. And then here you will have negative 8 times negative 1, it's positive 8. So minus 8 plus 8, that becomes 0. So the left hand side will just be 12. While on the right hand side, look at this. X equals negative 1. This x squared plus 4 at x equals negative 1, that's still 5. Okay? Same is true with this guy here. Okay? So this is 5. And then x equals negative 1 here, negative. So here we will get minus 5a. And then plus, again, that's 3 times 5. So that's 15. And then in here, what we will get is minus c plus d. Correct? Minus c plus d. And of course, negative 1 squared is positive 1. So we will have minus c plus d. Okay? So in here, in these two equations here, we can easily solve for d. Okay? If we add this equation here and this equation here, 5a minus 5a will cancel, c minus c will cancel, and then we will get here 2d. Okay? So let us do that. Let us do that. So adding the two equations, we will get what? On the left hand side here, we will have positive 8 equals. And then these two guys here cancel each other. Here we will have 30. And then these two guys here again will cancel each other. And then here you will have plus 2d. Okay? Which means that for our d, okay, this means that 2d, this is equal to what? 8, and then there is minus 30, that's minus 22, which gives us d equals minus 11. Okay, so this gives us d equals minus 11. So we have the value for d here, we have the value for b in here. Okay, then let's continue with our solution. Let me adjust this. Okay. Okay. All right. Then next, let's stop in here. And then what's next? We already have the value for D, so we are left with the value of, we just need to find a suitable value for A and C. That will help us solve this equation. Okay, so maybe we can have x equals 2, okay, x equals 2. So when x equals 2, we will get, so x equals 2, we have here minus 8 times 2 squared, that's 4. So minus 8 minus 32. Let me write that. So minus 32. And here you will have uh, minus 8 times 2. So that becomes minus 16. Minus 16. And then here you have your plus 12. Okay. That's your left hand side. For the right hand side, when x equals 2, so 2 squared, this is 4 plus 4, 8. So x squared plus 4, that's equal to 8 when x equals 2. And then 8 times 2 here, okay, 8 times 2 here, we will get what? So 8 times 2, 16. So we'll get 16a. And then b equal 3. So what do we have in here? X squared plus 4, that's 2 squared plus 4, that's 8 times 3, so plus 24. And then here we know that d equals minus 11, so we substitute this with minus 11, so that we will have what? X squared, that's 4 squared, that's 2 squared, so 4. And then x here, that's 2, so 4 times 2, that's 8c, so plus 8c. And then this is minus 11, 4 times minus 11, that's minus 44. Okay, or let us simplify this. We have minus 32 minus 16 plus 12, that's minus 36. Okay, equals here 16a. And then here 24 minus 44, that's minus 20. So minus 20 plus 8c. Okay, or let us simplify this. We bring minus 20 on this side, so that becomes plus 20. So let us write it this way. 16a plus 8c. This is equal to minus 16. Okay, and then let's use one of these. Okay, let us use one of this. So we will have, say, this guy here. We have 5a and then plus c equals. So here we have minus 4. We bring the, so we have here 15, and then d is equal to negative 11. So 15 minus 11, that's 4. Okay, that's positive 4. So if we bring that to the other side, we will have minus 8. Okay, and then what? So we solve this guy here. So we have 16a plus 8c equals minus 16. I'll multiply this second equation by negative 8. So that will get minus 48 minus 8c equals. So minus 8 times minus 8, that's equal to 64. And then we solve for a. This is minus 14a. So 16 minus 40. Oh, that's minus 24a. That's minus 24a. So minus 24a. And of course, HC minus HC, that's 0, and then if you added this guy here, we will get what? 8, 48, okay? Which means that A, is equal to minus 2, okay? Equal to minus 2. And therefore, we can use this. We can use this to solve for C, okay? To solve for C. So C will be equal to minus 8 minus 2 times 5, that's minus 10. We bring it to the other side. That becomes plus 10, which is now equal to positive 2. Okay? So, look at this. This guy here, forgot the dx. This guy here can now be written as integral of minus 2 over x, b it's 3, so plus 3 over x squared, then plus c equals 2, so you will have 2x, and then d equals minus 11, so minus 11 divided by x squared plus 4, close dx. Okay? Okay, so let's copy this and integrate this on the other side or on the next page. So I have this expression here. Okay, so this guy here can now be rewritten as, so we separate this. Let's just separate this. Okay? The reason is, if we separate this, we have 2x in the numerator and we have here x squared plus 4. So we can let u be equal to x squared plus 4, du will be the 2x. So the first part, the 2x over x squared plus 4, is just u substitution. While for this minus 11 over x squared plus 4, it's just trig sub, or if you recall, it's the arctangent. Okay, it's your arctangent. So again, let me rewrite this as minus 2 over x plus 3 over x squared plus 2x over x squared plus 4 minus 11 over x squared plus 4 dx. So for this, we will have minus 2 ln absolute value of x, and then here, remember it's squared, so let me clarify that. That's squared, so x raised to negative 2, we integrate that, we'll get minus 3 over x. And then here, we do the substitution, okay? Let me use this color. We do the substitution, u equals x squared plus 4 du equals 2x dx. Okay? So we'll just have integral 1 over u du, which means that this is just plus ln absolute value of x squared plus 4. So for clarity, du here is equal to 2x dx. And then for the other guy here, we have minus 11, and then check that this is what? Arctan. So arctan of x over 4. Correct? Arctan of x over 4. And then you have the plus c in here, which, therefore, we combine everything. Therefore, the integral of 2s to the 4 minus 8x plus 12 divided by x to the 4 plus 4x squared dx equals. So going back to the previous page, you have your 2 dx, so that's just 2x. Okay, that's just 2x, and then plus the integral of this. But the integral of this is this guy, and we have written the integral on the next page here. So here we have 2x, and then this guy is here. So for completion, I'll just rewrite the final expression here. So minus 3 over x plus ln absolute value of x to the x squared plus 4, and then minus 11 arctan of x over 4, oh, x over 2. Sorry about that. So this guy here, it's x over 2, not x over 4. Okay, so you have your x over 2 and then plus the arbitrary constant. So this is the final expression. Okay, one direction here, this should be 11 over 2. Okay, so 11 over 2, and therefore this must be 11 over 2 also. Okay, so this is the correct final expression. So for our last problem, we want to integrate 1 over 3 sine x minus 4 cosine x dx. So it looks like this problem here is misplaced. But actually, this one here, this integral here can be solved using integration by partial fractions. So the question is, how are we going to convert this integrand here into some rational expression? So we have a hint here. So we let t equals tangent x over 2, where x is between negative pi and pi. Okay? So let's start with that hint. We have t equals tangent x over 2. And if we look at the triangle, okay, let us look at some triangle here. Say d is your x over 2. So tangent it's opposite over adjacent. So this becomes t here. And then this is 1. And of course this is 1 plus t squared. Okay? Now, recall that sine, let's say sine squared of x over 2, this is equal to 1 minus cosine x over 2. Okay? But according to this triangle, what is sine x over 2? Sine x over 2, that's opposite over the hypotenuse. Correct? So sine x over 2, that's opposite over the hypotenuse. And therefore, what? The sine squared x over 2 becomes t squared divided by 1 plus t squared. Correct? opposite over the hypotenuse squared. And similarly, your cosine squared x over 2, according to our identity, this is 1 plus cosine x divided by 2. And according to this triangle, cosine squared x over 2 becomes what? Adjacent over hypotenuse squared. So this is 1 over 1 plus t squared. Okay? So what we're going to do is to multiply these two guys here. Okay? We multiply this guy and this guy. So if we multiply them, we will get 1 minus cosine squared x divided by 4. So we multiply these two guys. On the right hand side, we multiply these two guys, which gives us t squared divided by quantity 1 plus t squared quantity squared. Okay? But what is 1 minus cosine squared? That's sine squared of x. And then here we divide by 4. This gives us sine squared of x equals 4t squared divided by 1 plus t squared quantity squared, which gives us now sine x equals 4t or 2t divided by 1 plus t squared. Correct? So we have now the value for sine x. What about the cosine x? Well, we know sine squared x or the cosine squared x is 1 minus sine squared x. So let's write it here. We have cosine squared x. This is equal to 1 minus sine squared x. This is equal to 1 minus. We have this guy. Okay, we have this guy. We have 4t squared over 1 plus t squared quantity squared. And this will give us what? Let's square this. Let us square this. We will have 1 plus 2t squared plus t to the 4. And then we have minus 4t squared divided by 1 plus t squared quantity squared. And if you simplify the numerator, you have 2t squared minus 4t squared. That becomes minus 2t squared. So essentially the numerator now, it's 1 minus t squared quantity squared divided by 1 plus t squared quantity squared. So cosine squared or cosine x, rather, this is equal to 1 minus t squared divided by 1 plus t squared. So we have the value for sine x, we have a value for cosine x. All we need to do is to substitute it here. Okay? So here we have the integral. Let's write the x up there. Oops, forgot. We have here dt. Okay? Or do we need that? Nope, we don't need that. So we'll just substitute. Oh yeah, we will need that because we are changing everything by with the variable t. So in here, dt, this is equal to 1 half secant squared x over 2 dx. But what's secant squared x over 2? That's coming from here. correct? That's coming from here, and we have this guy here, correct? So secant squared of x over 2, that's 1 over cosine squared x over 2. But cosine squared x over 2 is 1 over 1 plus t squared, which means that um, this gives us what? Dx equals 2 dt divided by secant squared x over 2, or simply uh, this is 2 cosine squared x over 2 dt, which gives us, this is your cosine squared x over 2, so we'll just have 2 over 1 plus t squared dt. So now the ingredients are complete. We'll just have to substitute this sine x, this cosine x, and then this dx in here. Thus, we have here 2 dt divided by, let me rewrite it here, so 2 dt divided by 1 plus t squared. And then in here, we have 3 sine x on the denominator, but sine x is 2t divided by 1 plus t squared. And then here minus 4 cosine x is 1 minus t squared divided by 1 plus t squared. So if we simplify this, okay, we distribute this 1 plus t squared here, that will cancel this guy here, 1 plus t squared here and 1 plus t squared here. Which means we will be left with the integral 2 dt divided by 3 times 2, that's 6 t, minus, here you have minus 4, and then plus 4t squared. Then we divide that by 2 out of the expression here, and so we will obtain dt. For the denominator, we also rewrite this in standard form. So we write this as 2t squared, and then here you have plus 6 or plus 3t, and then we have minus 2. Okay, so I'm leaving this as an exercise. You see that we now have a rational expression in the integrand, so we can use integration by partial fractions. And the denominator here is factorable. Okay, it's factorable. So just try to factor it, and then you will get an answer in terms of t. And don't forget to bring back that t here. Okay? So that's the end of my discussion, and thank you for listening. Bye bye.